What's up, everybody? Welcome to another video. I hope you're ready to flex those brain muscles. First of all, let me just say thank you to all my new subscribers and new viewers. I've had a little bit of a boost in the past week. Maybe it's because we're headed toward finals week, but I just want to say thank you guys. This is what I love. This is what I'm passionate about. And it's pretty cool that I get to just do what I love and people will care enough to watch. That's a good feeling. So in this video, I'm really excited. We're doing final exam review for college algebra and pre-calculus. So this video, or should I say videos, because it's going to be a video series, right? I'm doing college algebra, and this is the famous 109 question college algebra review that is given out by the Texas State Math Department. So both the college algebra and pre-calculus final exams are departmental, and the cool thing about that is we get a departmental final exam review. So as a tutor, I'm very familiar with this, and it's actually the same as it was last semester. So I've seen a lot of these problems several times. And that's part of what kind of prompted me to make this video, is because a lot of people these past couple weeks to prepare for the exam, they want to come in the lab and they want to do every single problem. And a lot of them need help on almost every single problem, right? And since the lab gets so busy, it's really hard for those students to get help with all those problems just because the tutors get busy and we can't sit down one-on-one with you and work out, over 50 problems or something like that, right? So that's what excites me about making these videos, offering this resource for people who feel like they need that extra help. So what you can expect is that I will work out each problem, obviously. I'll probably split it up into parts. I don't really know how many yet, how long it will take. Hopefully not too long, but I'm assuming this is review, so I'm not going to break down each topic in depth, super thorough. I'm just going to do the example, talk a little bit about it, and then move on. But I do have on my channel, if you check it out, I have playlists with algebra, trig, and pre-cal, and you can go, and there I have like little mini lectures where I actually break down each topic and go pretty in depth. So if you don't get what you need from this video or one of these videos, maybe check out some of my others. And if none of my videos have what I need, then you can come see me in the lab, or there's plenty of other YouTubers who make math videos, so you can check those out. So yeah, what you can expect from this video is, again, for me to work out each problem. And what I'll do is, in case you don't go to Texas State University and you still want to follow along to review for your final, or maybe you somehow lost your 109 question review, I'll put that in the description, the PDF, the link to the PDF. You can download it, print it, do whatever you want to do. All 109 questions, and actually all the solutions are in the back, so you know the answers. Maybe you just don't know how to get to the answer, and that's the point of this video. So you can click down there. Also, I will have timestamps. So every single question that I cover in this video will be timestamped in the description. So if you're coming in and you just want to see the answer to question number 12, you can go straight down to the description, click number 12, watch that explanation, and then exit the video. So again, thank you guys for tuning in. We're about to start, but I just want to say, please share this with your classmates. This is a chance for me to kind of get myself out there as someone who loves helping people with math, So yeah, share this with your class, and hope you enjoy. Hope this helps everybody. All right, let's go ahead and start. Number 1, solve the rational equation. So rational equation just means an equation with fractions, all right? So our goal here is to solve for x. And normally what we do with rational equations is we try to clear the fractions. We want to get rid of the fractions because the fractions just make things harder for us. We want to get rid of them. So the strategy is I can multiply both sides by something. What always works is basically if I multiply all the denominators together, that number always works. So I can multiply both sides by x times 2 times 4, that's 8x, and that would get rid of all the fractions. But in this case, the 2 and the 4 share a common factor of 2, right? So I can actually just multiply both sides by 4x. That will get rid of this x, that will get rid of this 2 and this 4. So maybe you noticed that. If not, the 8x would have worked as well. But 4x saves us some time. We don't have to simplify as much at the end. So I'm going to go ahead and multiply both sides by 4x. So times 4x. This is times 4x. These 4's cancel. I'm left with x here on the right-hand side. What do I have on the left side? 4x times 3 over x. The x's cancel. And I have 12 plus 4x times 5 over 2. The 4, let's see, the 2 goes into the 4, so I'm left with a 2 on top. So 2x times 5, that's 10x. Now I need to solve for x, so I need to get x by itself on one side. So either way, I can move x this way, the 10x this way, or the x this way, whatever your preference is. I guess I'm going to move the x over here by subtracting x from both sides. And I'm going to get 9x here. So now I have 12 plus 9x equals 0. And then I can move the 12 over here. So it's going to be 9x equals negative 12. I just subtracted both sides right? I subtracted 12 from both sides. So now I simply just divide both sides by 9 to solve for x. And I'm left with x equals negative 12 over 9, which can be simplified. They share a common factor of 3. So 3 goes into negative 12, let's see, 4 times, and the negative just hangs out in front there. And 3 goes into 9 3 times. So this is my final solution, is x equals negative 4 over 3. All right, so number 2 is similar. We got a bunch of fractions. We want to just go ahead and get rid of the fractions. So I'm going to show y'all real quick a trick so you know exactly what number to multiply both sides of this equation by. And what you're going to do is something called prime factorization of each denominator. So basically what it means is I can break up each number into a product of prime numbers. So 4 can be broken up into 2 times 2. 5 actually can't be broken up. 5 is already prime. 10 can be broken up into 5 times 2. And 1 is just, I mean, I could write 1, but it's not going to affect my outcome. So then I have 2 times 2 times 5 times 5 times 2. So what I do is I write all of these up top, 2 times 2 times 5 times 5 times 2. And I divide on the numbers that I have pairs of, right? So I can circle a pair of 2s, that means I can divide by 2, and I can circle a pair of 5s, that means I can divide by 5. And this would have worked in the last example as well. Remember I said they have a common factor? That's what these common factors are, 2 and 5. So this 2 cancels with the 2, the 5 with the 5. I'm left with 2 times 2, that's 4 times 5, that's 20. So if I multiply both sides by 20, that's what works to basically cancel everything. And it gives me the, I don't have to do as much simplifying at the end. I could have just taken 4 times 5, that's 20 times 10, 200, and multiply both sides by 200. That would have worked, but it's extra work because I got to simplify more at the end. So I'm going to go ahead and multiply both sides of this by 20. And if you've never been shown that trick, yeah, I don't know. It's pretty cool. That's what I think of. Sometimes it's easy to recognize. With the last example, it was easier. When we get 3 numbers, it gets trickier. So 20, let's see, 4 goes into 25 times. So I'm left with a factor of 5 up top. And then here I minus 5 goes into 24 times. So 4 times n plus 2. And then this is equals. And then I have what? 10 goes into 22 times. 2 times n minus 4, and then this is just minus 20. So now I basically just need to distribute, like do all this multiplication and combine all my like terms, and I'm good to go. So 5n minus 15 minus 4n. This is a very common math mistake. They'll say plus 8. The negative needs to carry over and distribute. So minus 8. Be very careful with that. Very common mistake. 2n minus 8 again minus 20. So now I can combine my like terms on each side. So I have 5n minus 4n, that's n. And then I have negative 15 minus 8, that's negative 23. And this equals 2n minus 8 minus 20, that's minus 28. So what I'm going to do is subtract n from both sides. Minus n, we'll get rid of that n. And minus n here will leave me with n on the right hand side. I didn't mean to cross that out, I guess, but hopefully this makes sense. N minus 28, and I still have the negative 23 on the left hand side. So now I can add 28 over to both sides. So I add 28, hopefully y'all can see down here on the board. Add 28 to both sides, and I get n, let's see, that cancels this guy here. I get n equals, excuse me, n equals positive 5. And there we go. All right, for this equation, it says determine whether the equation is a conditional equation, an identity, or a contradiction. So conditional equation means this is true under a certain condition, meaning if I evaluate this, I get something like, y equals 5. I get y equals some number, all right? Identity means that this is always true, meaning I'll end up with something like y equals y, right? Always true. Contradiction means I'm going to end up with something that is never true. 2 equals 4, right? Something that just doesn't make sense. So those are my 3 possibilities. So really at the end of the day, what do I have to do? I have to just evaluate this, right? Simplify it all. So 13y plus 2 times 3, that's 6. 2 times negative y, that gives me minus 2y equals 5 plus 11y plus 2. All right, so what am I going to do? I can go ahead and combine some like terms. 13y minus 2y, that's 11y. Plus 6. On the right hand side I have 5 plus 2, that's 7, and I still have the 11y as well, 11y plus 7. Maybe you can already see what's going to happen here. When I subtract 11y from both sides, what's going to happen? You can pretty quickly notice. 11y is gone, 11y is gone. 6 equals 7. Contradiction, right? 6 equals 7 is preposterous. Contradiction. It's never true. It's absurd. So, contradiction. All right, number 4. So for these longer kind of word problems, I'm obviously not going to write it on the board just to save time. So really you have to have the sheet in front of you. That's why I put it in the description in case anybody doesn't have it. So in the mid-19th century, explorers used the boiling point of water to estimate altitude. The boiling temperature of water, T, in Fahrenheit can be approximated by the model T equals negative 1.83 A plus 212, where A is the altitude in thousands of feet. That's very important. A is in thousands of feet. Determine the temperature at which water boils at an altitude of 26,000 feet. So really the point of this question is it wants you to recognize that what we have here is a function, and it wants you to know how to evaluate a function at a certain value, right? So our function T depends on A, where A is the altitude in thousands of feet. And it's asked, determine the temperature at which water boils at an altitude of 26,000 feet. So we're plugging in, what are we plugging into A, right? Because we want to end up with a temperature, so we want to get T. So what can I plug into A? Let's see, negative 1.83. So what I plug into A is not 26,000, but 26, right? Because A is measured in thousands of feet. So we have 26 of those thousands, right? So that's another like kind of little trick with this question, I guess, is that it wants you to be able to know to plug in 26 and not 26,000. So if you punch this in a calculator, you will get 164 degrees. All right, so now we're being told to simplify an expression. So this is the expression we're given. The first thing that jumps out to me that I notice is that we have negatives under square roots. That means we're going to end up with i's, right? And if you remember, I, what does I represent? I represents the square root of negative 1, all right? So that's how we simplify this. As we rewrite this, and you can think of it as rewriting it this way, as negative 1 times 4, right? Because that's really what negative 4 is. And this is times negative 1 times 3. And with our square roots, we have this property where if I have two numbers under a square root being multiplied, I can split them up into the square root of each number, right? These two things are equivalent. So that's what it wants you to notice here, is that you can pull out the square root of negative 1 as I, and you can evaluate the square root of 4 as 2. So really what this turns into 2I here, times, you can pull out, again, this negative 1 as I, and the root 3 you can't actually evaluate. I guess you could if you wanted to get an estimation and plug it in a calculator, but that's not what it wants here. So if you evaluate this, we have what? 2I squared root 3. All right, so I'm going to write the I squared out in front times 2 root 3. So what exactly does I squared represent? Let's think about it. If I is square root of negative 1, then I squared is what? Square root of negative 1 squared. What do I get when I square a square root? They cancel, right? So I'm left with just negative 1. So I can replace this I squared with negative 1. So my final simplified form of this expression is negative 2 root 3. All right, so for this question, we are asked to simplify. So we just have to really remember that I is the square root of negative 1. And I squared, right? And you can, if you remember I, you can find all these other values, right? Because just think about squaring both sides of this. You get negative 1. Then we can square I squared. That's I to the 4th, and that's positive 1, right? Negative 1 squared, positive 1. And then we can kind of fill in this gap here with I cubed. I cubed equals, what does it equal? Well, I squared is negative 1 times the square root of negative 1, which you usually just write this as I. So really what we have here is negative I, all right? So if we think about this as a pattern, how does this continue? I to the 5th, that's what? That's I to the 4th times I, all right? So I to the 5th equals square root of negative 1, right? Because I to the 4th is 1 times I, which equals I. So that's kind of, these are the rules we use, and we use this pattern. Basically, we can subtract multiples of 4 from this exponent, and this will still be equivalent. So I basically need to divide this by 4, and I'll be left with the remainder, if that makes sense. So if I divide 31 by 4, I can do it that way, and I'll be left with a remainder of 0.75, which tells me that I have an exponent of 3. You could think of it that way. The way I like to think of it is I think of sort of putting 4 into, like dividing 4 into 31. And I know it can go in 7 times, and that gives me 28. So that I basically can rewrite this as I to the 28th times I cubed. And I know that since this is a multiple of 4, that's just 1, right? This is 1, so that can go away. So what I'm really left with is I cubed, which is negative I, all right? So hopefully that makes sense. The final answer is negative I here. Really, you just got to, take out multiples of 4 and then evaluate or simplify whatever you're left with. All right, we're going to perform the indicated operation and write our answer in the form A plus BI. So you'd call A basically the real part, and BI would be basically the complex part of our solution. So let's go ahead and start. What do? We FOIL, all right? Negative 6 times 8, that gives me negative 48. So that first, let's see, outer, negative 6 times 9i, that gives me minus 54i. Now I'm doing inner, negative 8i times 8, that's minus 64i. Okay, first, outer, inner, last, negative 8i times 9i, that gives me negative, let's see, 9 times 8, that's 72i squared, all right? So now I can simplify this, and what can I notice right off the bat? That I squared is actually just negative 1. So this will become negative 72 times negative 1, which makes it a positive 72. So I'm going to go ahead and notice that, and I'm going to rewrite that 72 out here in the front because I can combine these like terms now, right? And I can go ahead and combine these like terms. Let's see, what is minus 54 minus 64? I think that is minus 100, let's see, 18. Is that true? You might want to double check me on a calculator. 118i there. So this is what I've simplified to. Now I just combine these like terms, and I'm left with what? 24 minus 118i. And that should be, yep, that's my final solution. So we are good to go there. And that is in A plus BI form. All right, so for this problem, there is a little trick to it, and the trick is something called the conjugate. We're going to use the conjugate, which is basically we take this denominator and we multiply top and bottom by the denominator, except we change the sign in between these two terms. So I have 5 minus 9i over 5 minus 9i, because this is an expression. Whatever I multiply by has to be something that's in the form of 1, right? This equals 1 because it's something over itself, because I can't change the value of this expression. So this conjugate, it's kind of a trick, because what it ends up doing is actually canceling this imaginary, this complex term in the bottom. So let's go ahead and see how this works. 5, well, I'll do the top first. Negative 2 times 5, that gives me negative 10. And then I have plus 18i. And then I have plus 15i. Right, let me double check that. Negative 10 plus 18i plus 15i minus 27i squared. All right, and on bottom I have 5 times 5, that's 25, minus 45i plus 45i minus 81i squared. All right, so look what happens and how this conjugate works so nicely is that my middle terms cancel, plus 45i minus 45i. That's gone. What happens to this I squared? I can rewrite that as a negative 1 as well as this I squared on top. So this actually works out pretty nicely. So if I rewrite this I squared on top as negative 1, that becomes plus 27. I'm going to rewrite the 27 up here. So I have 27 minus 10. I just moved it around. It's addition and subtraction. I can move it wherever I want. So 27 minus 10 plus, I'm going to combine these as well. They are like terms, 33i. And have that over 25 minus 81i squared. Again, that's negative 1. So this is plus 81. So I have 25 plus 81. That is 106. So I have 106 on the bottom. All right. Can I simplify this top a little further? I can. Let's see. I have 27 minus 10. That is 17 plus 33i over 106. And because it wants it in A plus BI form, I would guess that it wants us to split this up. Since we have a single term in the denominator, we can split this up as 17 over 106 plus 33 over 106i. All right, I'm guessing that's how it wants us. That's how the form wants it. Let me double check, and we are good to go. So this is our final solution. All right, so we're given this equation, and we are told to solve the equation. So we notice that it is a quadratic, right? We're missing a constant term, but that doesn't matter. It's still a quadratic. So what we need to do is try to factor, first of all. So the first thing I notice is that these two terms share a common factor of y. So I'm going to factor out the y out front. So this is y times y minus 20. And now actually I already have what I need. It's set equal to 0. I have two things being multiplied together that equals 0. That means y equals 0, and that means y minus 20 equals 0. All right? If I add 20 to both sides, I get y equals 0, y equals 20, and those are my two solutions. Pretty straightforward. So when solving quadratics, you always want to get 0 on one side and then try to factor. If for some reason you can't factor, then you can use the quadratic formula. But you always get 0 on one side and try to factor. So that's exactly what I'm going to do here. I'm going to subtract 6y from both sides, minus 6y minus 6y. And that leaves me with y squared. And I'm going to put this minus 6y in the middle here because that's the form I want my quadratic to be in. And this equals 0. I have it exactly how I want it. So now I need to factor this. It's a trinomial. So I know that if it is factorable, that it's going to be something like this. Two binomials with y in the first term of each binomial. So I'm looking for two numbers that multiply together to be 13 and add together to be negative 6. Shit, that doesn't work, does it? 13 is prime. So, yeah, that doesn't work. So I got to go quadratic formula. Let's go ahead and go quadratic formula. But it's always a good first try is to try to factor first. I'm doing this on the fly, like I said. I had the solutions written down, but I'm just doing these organically. I'm confident in my ability. So A is that leading coefficient. These correspond to the coefficients. C equals 13. So remember, I remember the little song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I know you probably just cringed, but that's the song I remember. So x equals negative b, that's negative 6, plus or minus the square root of, b squared is in here, that's negative 6 squared. I'll just go ahead and write that part out. B squared minus 4 times a times c all over 2a. So that's just 2 times 1. So I have here 36 minus, let's see, that becomes what? 52? Ooh, these are complex solutions. This is cool. X equals 6 plus or minus the square root of, yeah, they're complex solutions because we're going to have a negative under the square root. We're going to have to pull an I out, all right? So this is 36 minus 52. What does that give me? 36 minus 52, is that negative 16? Does it turn out to be nice like that? That's pretty nice that that's how it works out. So again, I could rewrite negative 16. I'm running out of room down here, so I'll do it up to the side here. Negative 16 is like saying negative 1 and 16. And 16 can come out as 4, negative 1 could come out as I. So if I rewrite this, I have 6 plus or minus 4i over 2. And if it wants you to write it in the a plus bi form, again, you'd write 6 over 2. That would simplify to 3. And then you'd write plus or minus 4i over 2. That would simplify actually to 2i. So my final solution, I don't know if y'all can see it on here. I'll write it here, is 3 plus or minus 2i. And yeah, I just separated this, and both of these are divisible evenly by 2, so I simplified it a little bit, and now we should be good to go. So 3 plus 2i is one of my solutions, and 3 minus 2i is another solution. If you want to list each one out, you can do that as well. All right, so number 11, I'm asked to solve the equation, but I'm specifically told to use the square root property. So what the square root property means is I basically get something squared on one side equals some number, and I take the square root of both sides, all right? So that's what I'm going to do is I have something squared here, and I'm going to isolate that something squared equals something. So I can immediately add 6 to both sides, plus 6, and that leaves me with 3 times x plus 6 squared equals 450. Then I can divide both sides by 3. I want to get that something squared. It doesn't matter what that something is. I can use the square root property. So x plus 6 squared equals 150. All right. So now what can I do? Square root both sides. That's going to get rid of that squared. But the one thing I have to remember, is that when I square root, I have to plus or minus, all right? It's part of the square root property. So I have x plus 6 here equals plus or minus square root of 150. So basically, I'm going to subtract 6 from both sides. So those are my solutions for x, but I'm probably going to be able to simplify this a little. So let's see, where can I write it? I'm going to move up here. So I have x equals, again, I subtract 6 from both sides. That gets rid of my plus 6, cancel. So I have x equals this plus or minus square root of 150 minus 6. How can I simplify square root of 150? I'm basically trying to pull out something that's a perfect square out in front. So 25 is what jumps out to me. Basically what it means is that I can rewrite this as 25 times, what is it? 5? No, not quite. Times 6. Times 6, because that gives me 150, and I can pull out 25 as a 5, right? So I can pull out 25 as a 5. So what is my final solution? I'm left with x equals, let's see, and I can bring the negative 6 out in front if I prefer that. Negative 6 plus or minus 5 root 6 is what I'm left with. And yeah, it depends. I mean, some people want you to list out, because this is 2 solutions. I just want to make that clear for everybody. This is 2 numbers. The plus or minus means 2 numbers. My first solution for x is negative 6 plus 5 times square root of x. My second solution is negative 6 minus 5 square root of x. So as long as you understand that it's 2 solutions, you're good. I think it's fine to leave it in this plus or minus form. It just depends on the instruction of the professor. It's getting warm in here, so I'm taking a quick break. This Creamy Creations chocolate chip was on sale at H-E-B. $1.50 for a pint. That's crazy. All right, and we're back. So we have a word problem for number 12. I'll go and read it. Ramon wants to fence in a rectangular portion of his backyard against the back of his garage for a vegetable garden. He plans to use 84 feet of fence and needs fence on only 3 sides. Find the maximum area he can enclose. So pretty much all these problems where it's asking to find some kind of maximum, you're going to end up with a parabola, right? You're going to end up with a quadratic that you can find the vertex of. It's going to be a quadratic that opens down. So the vertex will end up being the maximum, right? So you can either complete the square or use that negative b over 2a trick and then go back and plug that in. But that's going to be the process on all of these. So really the only tricky part is setting it up. So let's draw a little picture. This is like the garage, and this is the fencing. It says a rectangular, so that means that these side lengths are the same. This one can be different. So what do we have that's 84? Let's see. The perimeter, the length of like these 3 sides is 84. So that means x plus y is 84. So I can write that as 2x, right? 2x plus y, because x plus x is 2x. That equals 84. And what am I trying to maximize? The area. So I have area, which is what? That's length times width. It doesn't matter that I'm missing a side. This is closed off by the garage, or whatever it is. Garage. So the area is still the area, whether that side is fencing or garage. It's still x times y. So this is what you'll have with all these kind of problems. You'll have 2 equations, and you'll do some kind of substitution, right? So if I do a substitution here, and I can do it for x or y, but I'm going to do it for y, because if I did it for x, I'd have to divide by 2. I'm going to solve for y, so I'll draw a little arrow here, and I'll subtract 2x from both sides. What do I get if I subtract 2x from both sides? I get 84 minus 2x. So I've solved for y, and now I can do a substitution, which is I can plug y, basically substitute in y in terms of x. So I have area equals, if I write all this in terms of x, I have x, and then I substitute this in. Y equals this, so I can replace y with that. 84 minus 2x. Now I can distribute the x, all right? And what I'm going to be left with, as you can see, is a quadratic, just like I suspected. And it is a quadratic that opens down. That's how it's always going to be, because a quadratic that opens down, right, the vertex, the y value that corresponds with the vertex, that is the maximum. So that's how these are all going to work out. So let's see, did I go ahead and distribute? Yeah, this is good. So I can use my negative b over 2a. That's probably the best way to go about this. So it would make more sense to rearrange this, because otherwise I could use the wrong thing for negative b over 2a. This is my a, right? It's in the wrong order technically, but I have negative 2x squared plus 84x. You might not have to rewrite it like this, but it's really important to recognize that this is a and this is b. All right. So negative b over 2a would be negative 84 over 2 times negative 2. That's negative 4. The negatives cancel and I get 21. So again, this isn't my maximum, but this is the value for x, right? This is the value for x that happens, that maximum kind of happens at, right? When I plug in 21, that's when I get the maximum, is what I'm trying to say. So what exactly is it asking for? Find the maximum area. So I have the maximum value, the value for x that gives me the maximum area. I just need to find y. So I can simply plug in this 21 into this x here, and I get y equals 84 minus 21 times 2 is what? 42. And that equals what? Y equals 42. All right. So does that mean my area is 42 times 21? Let's make sure that's right. Area equals 42 times 21. And when I go ahead and multiply that out, I get 882. So that is my maximum area. So it's a bit of a process. It's kind of hard to set up, but you got to do some substitutions, and then you got to find the vertex, and then make sure you know what you're getting when you get the vertex. You're getting that x value, that negative b over 2a. That's the value for x that the maximum area happens at, right? You got to go back and find the y, and then find the area for this specific problem, okay? So yeah, let's go ahead and move on to the next problem, which is a little bit similar. All right, so for number 13, we are told the length and the width of a rectangle have a sum of 88. So if we call, again, the length x and the width y, we know x plus y equals 88. All right, if we do a rectangle here, y'all probably can't see the top of this. Let me move this down a little bit. I'll move this down over here. So if we have a rectangle here, this is x, this is y, so length plus width equals 88. What dimensions give the maximum area? So again, area is x times y. So this is actually the same exact process. It's almost the same problem, just with different numbers, and the substitution is actually even easier. If we solve for y this time, we have y equals, we subtract x from both sides, right? 88 minus x. This is almost the same problem. It's a little bit repetitive, but I guess they want you to get plenty of practice in. So then what do? I go back and substitute this in for y, because I'm going to end up with a quadratic. So I have x times 88 minus x. When I distribute this x, I get 88x minus x squared. My a is negative 1, my b is 88. So I have negative 88 over 2 times negative 1. That equals 44. So that is the x value that my maximum area happens at. So what is this asking for? Ooh, it's asking for the dimension. So always go check, because they can trick you with what they're asking for. It's asking for dimension. So we're going to end up with x and y, not area like the last problem. So I have my x. I can go back and plug it in to find my y. So then I have y equals 88 minus 44, which actually ends up being 44 as well. So this is actually not a rectangle. Well, it is a rectangle. A square is still a rectangle, but it is more specifically a square. So we have length 44 and width 44. All right, so here for number 14, we were just given an equation and told to solve for b. So what it means to solve for a variable is basically I want to end up with b equals something. So I want to isolate b. So I can multiply both sides by 3 right off the bat, because if I multiply by 3, that'll get rid of this 1/3. 3 times 1/3 is 1. So I'm left with b times t, and that means I got to multiply both sides by 3. So I have 3v equals b times t, and since I'm solving for b, I can simply divide both sides by t, and I end up with, my t's cancel, and I end up with b equals 3v over t. All right, so same idea. This time we're solving for y. So we have t equals a times y minus a times y naught is what you'd call this. Yeah, if you've never seen this before, it's just a variable different from y. So we're just solving for y. It's the same as if this were like an x or something. It's just a variable. So same process. I want to isolate y and get y equals something. So right off the bat, I'm going to add a y naught to both sides. You know, because why not, right? That was a terrible pun. I'm sorry you even had to hear that. So I have t plus a times y naught equals a y. Wow, this is really straightforward actually. Now do I just divide both sides by a? I'm solving for y, right? Yeah, solving for y. So divide both sides by a, and that's actually it. So the a's cancel, and I end up with y equals t plus a y naught over y. I'm sorry, a. All right, so remember that when we're solving quadratics, we get 0 on one side. Well, it's the same with polynomials. The only issue is polynomials with, x cubed, this has 4 terms, they can be a little bit trickier to factor, okay? But what you should always try and what you should always look for is factoring by grouping. That's going to be the most common way that you end up factoring these polynomials with 4 terms. So that's what I'm going to do, is factor by grouping, and basically what that means is I can kind of group these terms together and these together, factor out something from these first 2 terms, and then I'm left with common terms, and I can factor those out to the front, and you'll see what I mean in a second. So what do I have in common between these first 2 terms? Well, I definitely have an x squared, right? Because this is x cubed, this is x squared. I can take out x squared, and I can also take out 25. So I can pull 25x squared out to the front. And what am I left with when I pull that out? I'm left with a 3x, and I'm left with plus, what am I left with here? Plus 5, is it just 5? That's 5. Minus 3x minus 5. So again, I want to get common terms here, right? So the trick, and this is a little bit tricky, but the trick here is basically what I'm going to do is factor out a -1. Because I want these to look the same. That's the whole point of factoring by grouping. I want these to look the same. They're almost the same. The only difference is that factor of -1. So I can simply just rewrite this and kind of think of it, that's how I think of it, as I'm factoring out -1, right? I'm pulling the -1 out in front. There's an invisible 1 there. You don't really need the 1 technically. But if I pull the -1 out, then I'm left with 3x plus 5. Now I have what I need. Now I have the common term, and I can factor by grouping. So again, the 25x squared and the -1 are what's left over. 25x squared minus 1. So you can think of it as this is the common factor, this is the common factor. These are both being pulled all the way out front. What I'm left with is 25x squared minus 1. That's what I'm left with. So what I pulled out in front was 3x plus 5. So think about if I took this whole thing and I put it back into that first part and put it back into that second part, then I will get back to where I came from. So since this equals 0, I could set each individual part equal to 0 and solve for x. So I have 3x plus 5 equals 0. Hopefully y'all can see down here. 3x plus 5 equals 0. If I solve this for x, I subtract 5 from both sides and then divide both sides by 3. 2 steps in 1. Hopefully y'all can handle it. I think y'all can. Subtract 5, then divide by 3. I end up with 3x equals -5. Then when I divide by 3, I have x equals -5 over 3. I did 2 steps at once. I think y'all can handle it. So that's one solution for x, but now I have to do 25x squared minus 1 equals 0. I'm going to do that over here. Hopefully y'all can see. That would be a bummer if this is all out of the picture. Minus 1 equals 0. So if I add 1 to both sides and then divide by 25, all right? So adding 1 plus 1 plus 1, that'll get me 25x squared equals +1. Now I can divide both sides by 25 and then square root both sides, plus or minus. Remember, always plus or minus. So if I divide both sides by 25, I feel like this is out of the picture now. Divide both sides by 25. I'm going to write it over here. I have x squared equals 1 over 25. Maybe I'll go back here to the top. Make some room up here. Hopefully I'll have this down. That's just the question that was asked. So what do I have? I'll start from here. 25x squared equals 1. When I divide both sides by 25, the 25's cancel. I'm left with x squared equals 1 over 25. Now I square root both sides. Remember to plus or minus. You have to plus or minus. There's 2 answers. So x equals plus or minus square root of 1 over 25. So x equals plus or minus square root of 1 over. I guess you could punch this in a calculator if you wanted to, but the cool thing about square roots is that if you have square root of like a over b, it's equal to square root of a over square root of b. So I could split this up as square root of 1, which is just 1, over square root of 25, which is 5. So this actually equals plus or minus 1/5. So I have 3 solutions for x. I'll go ahead and erase this part here. I'm sorry, this one was a little unorganized. So I have 3 solutions for x. I have x equals 1/5, negative 1/5, and negative 5 over 3. And since it's a set of solutions, I usually write these little curly, fancy brackets. And we're good to go. So quite a process with the factor by grouping, but always look out for factor by grouping when you have a polynomial with 4 terms that needs to be solved for x, right? Factor by grouping, always look out for that. All right, number 17, we are solving this rational equation for x. So the first thing I notice is that it is a rational equation, and I want to get rid of the denominators like any rational equation. So I need to multiply both sides of this equation by something that will get rid of all my fractions. So I notice that I have an x, x minus 5, and x minus 5. So I only need one of these factors of x minus 5, right? And I need this x. So I can multiply both sides by x times x minus 5. Because that will get rid of my x, and it'll get rid of both of my x minus 5s. And I got to multiply both sides by this. X times x minus 5. Bam. Okay, so what happens here is that my x's cancel, and I have 3 times x minus 5. 3 times x minus 5. Plus, what happens here? My x minus 5's cancel, and I have 3 times x. All right, what happens on this side? My x minus 5's cancel, and I have x times 3x minus 12. So now all I need to do is, do some multiplication, combine some like terms, simplify, and solve. So 3x, let's see, I'm distributing this 3 in. 3x minus 15 plus 3x. Those are going to simplify. I'll do that in the next step. 3x squared, right? My x is going in. Minus 12x here. Oh, we got a quadratic. I'm going to end up having to get everything to one side, 0 on the other side, and either factoring or using quadratic formula or something like that. So since this is positive, this 3 is positive, I'm going to move everything to this side. I'm going to be strategic about this because I like my leading term to be positive. It just makes things a lot easier when you're factoring and, that kind of thing. So 3x plus 3x, that's 6x. So what I really have here is 6x minus 15, all right? I guess I'll go ahead and rewrite it. 6x minus 15, 3x squared. I'm tempted to skip steps, but I want to show as much as I can here. So now I just need to get 0 on this side is what I choose to do here. So I'm subtracting 6x and adding 15 to both sides. That's going to give me 0 minus 6x plus 15. So now I have 3x squared minus 18x plus 15 equals 0. And what do I notice? These share a common factor of 3. I'm going to go ahead and pull that 3 out in front. All right? Let's see. So I have 3, and then here I have x squared minus 6x plus 5 equals 0. This actually factors pretty nicely, I think, right? Inside here, I'm looking for 2 numbers that multiply together to be 5 and add together to be negative 6. I think that would work with minus 5 and minus 1, right? Negative 5 and negative 1 multiply together to be 5 and add together to be negative 6. So this is going to factor into x minus 5 and x minus 1. And my 3 just kind of chills out front. The 3 actually doesn't affect when this equals 0. I can think of it as like I multiply both sides by 1/3 and get rid of it. 1/3 times 0 is still 0. So it's really insignificant for this part of the problem. So that means x minus 5 equals 0, x minus 1 equals 0. So that means my solutions for x, you can probably already see what it is. X minus 5 equals 0, x minus 1 equals 0. So you can probably clearly see that x equals 1 and x equals 5 are my 2 solutions. So I have x equals 1 and 5. All right, so now we're solving this equation with this absolute value. So I just have to remember that whatever's in the absolute value is going to become positive. That's what the absolute value does, right? So if I think about this, when will this whole thing equal 16? Well, that means everything inside of here could be 16, Or everything inside of here could be negative 16, because then when I take the absolute value, it will equal 16. So in this case, I need to set up two separate equations and solve them both. So I'll have 24z minus 12 equals 16. That's one of my possibilities. And then I'll have 24z minus 12 equals negative 16, because if this equals negative 16, then once I take the absolute value, it becomes 16. So it still makes this equation true, if you want to think of it in that way. So right off here, if I add 12 to both sides, these are both linear equations. You should be able to solve these pretty straightforward. 24z equals 28. Now I divide both sides by 24. And I get z equals 28 over 24. And I can simplify that. I can tell they're both even, so they're going to simplify. And I think they'll simplify pretty nicely, actually. What do I get here when I evaluate this? Let me check. 7 over 6, is that correct? Let's see, because 7 times 4 is 28, and 6 times 4 is 24. Yeah, that's correct. 7 over 6. Sorry, I just had to check my paper. I work all these out ahead of time, so that way, yeah, I don't have to pull out the calculator, and you know what I mean. So, again, I add 12 to both sides. And what happened here is the 12 cancels, but I have minus 16 plus 12. That's negative 4. So I end up with 24z equals negative 4. And if I divide both sides by 24, I get z equals, what is negative 4 over 24? Let's see. 4 goes into 24 6 times. So I think this is negative 1 over 6. Let me double check. Yes, it is. So my two solutions are z equals negative 1 over 6 and 7 over 6. All right, for number 19, we are asked to solve this equation. So the first thing I notice is that I have this square root with two terms and a variable. It's just kind of ugly. I don't want to deal with it. So with equations like this, basically what I want to do is isolate the square root and then square both sides to get rid of that square root. So that's exactly what I'm going to do. I'm going to add 5 to both sides here. And then what I have is square root of m plus 95. And this equals what? This equals m plus 5. All right? So now when I square both sides, I get rid of the square root. All right? So I'm left with m plus 95 on the left-hand side. And this equals m plus 5 squared. I'd be real careful. This common mistake made where you distribute the square. You say, oh, this is m squared plus 5 squared. Wrong. You got to FOIL this out, right? Because this means m plus 5 squared, which means times itself, all right? So there is kind of a shortcut formula. If you know that, that's fine. But otherwise, you can FOIL this out. So this becomes what? M squared plus 5m plus 5m. That's plus 10m. I did kind of two steps at once there. Plus 25. So that's exactly what I'm going to have here, is that m squared plus 10m plus 25. Now I can recognize this is quadratic. I got to get, 0 on one side. So I'm going to subtract m from both sides, and I'm also going to subtract 95 from both sides. So again, kind of doing two steps at once here. I think I can handle it. I think I are good. So m squared, what's 10m and minus m? That becomes plus 9m, right? Plus 9m. Those combine, those like terms. We have other like terms that combine. This becomes minus 70, right? 25 minus 95. And this all equals 0, okay? So now I can try to factor, and if I can't figure out how to factor, I can use the quadratic formula. But I always try to factor first. So I'm trying to break the 70 up, and I can do some scratch work off here. A lot of times you have to experiment a little. So that's what, 7 and 10? Will that work? Because I'm trying to get two numbers that add together to be 9. 7 and 10, I don't think that will work. What about something like, let's see, well, 15, does that go in? No. 7 and 10. What about 5 and what would it be? 5 and 14? I think that's actually what's going to work. I think it's going to be plus 14 minus 5. Yep, that's what works. Plus 14. So it is a little bit of a process. It takes me a little minute too, and I've been doing math like this forever. So take the time to do it, but it's still quicker than quadratic formula and cleaner, I think. So again, this means that m equals negative 14 and m equals 5. I skipped a couple steps there, but m equals negative 14 and m equals 5. I set each one of these parts equal to 0. I've done that a bunch in this video. That's why I just kind of skipped ahead to the answer is m equals negative 14, m equals 5. But what's the problem here is that with these square root equations, when you're solving them, you will get what's called extraneous solutions sometimes, which means a lot of times when you end up with some kind of quadratic and you solve and you get two answers, you have to go back and check and see if your answers work, because you'll have a bogus answer. That's just kind of how it works out when you solve these. So I got to go back and check my answers. So if I plug in 5, what do I get? 5 plus 95, that's 100. Square root of 100 is 10 minus 5, that equals 5, which is m, right? I plugged in 5. So 5 equals 5. So that works. M equals 5 works. What about m equals negative 14? All right? So that means that negative 14 plus 95, that comes out to be what? Negative 14 plus 9, that's 81. Square root of 81 is 9. 9 minus 5 is 4. But wait, 4 does not equal negative 14. So this actually doesn't work. And the reason we get an extra answer like that is because when we square both sides, we kind of change the equation a little bit when we square both sides. But we just have to make sure we go back and check our answer. So in this case, actually, our only solution is m equals 5. So yeah, just don't forget that when you have square root equations like this that you're solving, go back and check your answer at the end, because a lot of times you will throw out one of your answers because it won't work. All right, so for number 20, this problem I'm actually very familiar with because I probably helped 20 different students with this exact problem last semester. So it is pretty tricky. A lot of students struggle with it. So yeah, it's tricky just because we have to recognize that this kind of looks like a quadratic. And what I mean by that is that, what if I rewrote this as 3d to the 1/3 squared, right? These are still the same thing. When I take a power to a power, I multiply. Remember your exponent rules. So these are still equivalent. And now I can see that this is like 3 something squared, all right? Minus 4d to the 1/3. This is kind of like that same something that's being squared, that something is here. So this is kind of like 4x. And then minus 15 equals 0. So the important part is recognizing that the way you solve both of these, the process is the same. So you treat this as if it's a quadratic. So yeah, I did a substitution last semester. I taught, substitute in, but that tended to confuse a lot of students more. So I'm just going to keep it in terms of d to the 1/3, but you could do like a substitution. But really the idea is I'm going to solve this as if it's a quadratic. So I'm going to either factor or use quadratic formula. I'm actually just going to go probably straight into quadratic formula. Instead of having x equals, I'm going to have d to the 1/3 equals. All right? Right? Because my d to the 1/3 is kind of like my x in this case. So equals negative b, so that's negative 4. So that's 4 plus or minus, let's see, negative b plus or minus square root of, let's see, b squared, that's negative 4 squared. You got to sing the song. Minus 4ac, so that's 4 times a times c. That's negative 15 there. All over 2a, so that's 6. All right, we're good to go here. 4 plus or minus, I need to simplify all this stuff. That's 16 minus, let's see, 12. What is 12 times 15? It might be better to do this. 45 times 4, that's 180. And since I have two negatives there, I'm going to end up adding. So what this actually equals is 4 plus or minus the square root of 16 plus 180. Oh, that's going to be 96. That's a perfect squared. I think that's actually 14. The square root of 196 is 14. But let me go ahead and write out each step here. 4 plus or minus the square root of 196 over 6. So this actually equals 14. So my two solutions are 4 plus 14 over 6, which equals 18 over 6, which equals 9 over 3. Isn't that just 3? I don't know why I didn't just go straight to 3. Oh man, this video is long. All right, so I have one solution is 3. I'll write that up there. My other one is what? What do I do here? Plus, and now I got to do minus. 4 minus 14 over 6. That is negative 10 over 6, which becomes negative 5 over 3. So those are my two, but they're not quite solutions because these are what d to the 1/3 equal, and I want to solve for d, all right? So I need to go back and make some room here and basically set d to the 1/3 equal to 3, because remember that whole thing is what d to the 1/3 equals. So d to the 1/3 equals 3. So how do I get rid of 1/3? I cube both sides. So that means d equals 3 cubed, which is 27. That's one solution, all right? D to the 1/3 also equals -5/3. So if I cube both sides here, cube, I end up with, on the top, I have -5 cubed, that's -125. And on the bottom, I have 3 cubed, that is 27. So these are my two solutions for D. D equals -125/27 and 27. So this is a pretty tricky example. It is pretty tricky. So don't feel bad if you didn't get this, or if you still don't get it. Come see me in the lab if you have more questions. But yeah, I'm going to wrap up this video. It's getting pretty long, but I'm going to break it up into parts. I hope to cover every example in this review. I can't make any promises. I do have final exams of my own. But if this did help you, make sure to hit like and hit subscribe. Show some support in the comments. Let me know that this helped you. I love hearing feedback. It motivates me to make more videos, more content, help more people. So please do let me know if it helped in the comments, and keep flexing those brain muscles. You're going to crush your final exams. It's going to be great. So see you in the next video.